Okay, we don't have a whole lot of time left. We only got like 8 or 9 minutes, but we got some time to get started on this. So let's talk about this. We've already talked about a trapezoid. There's a trapezoid right there. So I was ready for it. What do we know about a trapezoid? Okay, it's got four sides. That's true. It's got one set of parallel sides, right? Okay, so this one and this one would be the parallel ones. Okay, we've got these things called base angles. We got these. The top and the bottom would be called a base. The two sides would be called what? Legs. All right. So we're going to get a little bit more specific than just a general trapezoid. Okay, this is an isosceles trapezoid. Isosceles trapezoid. You know what an isosceles triangle is, right? What's an isosceles triangle? What is it? Two equal sides. That's right, okay? Technically, the definition is at least two equal sides, but yeah, for the most part, it's two equal sides. Well, an isosceles trapezoid has exactly two equal sides, all right? And let's label it. So this is K, J, I, and H down here, all right? And so let's say that those are my two equal sides, okay? So the legs are the ones that are equal to each other. Everybody got that? So so it's called an isosceles trapezoid because two of the sides are equal. Pretty good. So we have a theorem that, in fact, I taught in my other CP class today. We did isosceles triangle. And I'll tell you what, let me just draw that super quick. Use this thing. Where is it? Okay. And then let's make three sides. There we go. All right. So this right here, actually, let's do it like this. So in my other class, we talked about this, that if I have an isosceles trapezoid, and so we talked about it with you guys at some point. Well, what chapter are they on? Chapter 4 they're on. And if you have two equal sides, what do we know about the opposite angles if I have an isosceles triangle? What do I know about this angle here and this angle here? I know something. Do you remember? They're equal to each other. That's right. The opposite angles are equal. Okay, so if I have two sides of a triangle are equal, then the opposite angles are equal. Well, a trapezoid has a lot of the same characteristics that a triangle has. All right, it's basically a triangle, except you just chopped off the top of it, right, parallel to the base. That's basically what this is. Wouldn't you agree? If I took that triangle and whopped it off right there, actually, let's just go from here to here. Watch, if I went from there to there, then I've got a what? Trapezoid. Everybody see that? All right, so there's a lot of similarities between trapezoids and triangles. So take a wild guess what you think might be equal to each other in this trapezoid, this isosceles trapezoid. Give me angles. Give me letters.
KH and JI.
They're angles. KH is an angle. Angle H and angle I. So angle H and angle I. And they are equal to each other, okay? And it's a theorem, okay? It's a theorem, and it's kind of based on this old theorem that we learned a long time ago, a couple chapters ago. So if you have two equal sides of a triangle, then the opposite angles are equal. Same thing here. If the two legs are equal to each other, it's an isosceles trapezoid. That means these two angles down here, the base angles, are equal. What must also be true about this angle here and this one right there? They're going to be equal to each other as well. Doesn't mean that they're going to be equal to this one down here, okay? But these two are equal to each other. Everybody good with that? Yeah. All right. Well, let's learn something else about a trapezoid. Anybody write that down? Be a good idea if you did. All right. I'm just going to make that look a little bit different. What do you think? What kind of question is that? Is it going to be on a quiz? Of course it's going to be on a quiz. Everything I teach you, everything I ever say in front of you, you should count as it's going to be on a quiz, all right? All right, here's another theorem. It says this. Which one do I want to do? Okay, so if a trapezoid has one pair of congruent base angles, then it's isosceles. So this is kind of like the converse of what we just talked about. So if I told you that this angle and this angle were equal to each other, what do you think I could say about that whole entire trapezoid? It's just backwards of what we just did. Before, we said if we had an isosceles trapezoid, then the base angles are equal. This one says if the base angles are equal, then it's a what? Isosceles trapezoid. Exactly right. So if they tell you that these two angles right here are equal to each other, that means that this side and this side, the two legs, are going to be equal to each other. Then it's isosceles, isn't it? Okay? So if either one, like they could have told you that these two are equal to each other, or they could have told you that these base angles were equal to each other. It doesn't matter, all right? If they told you that that was true, then what do we know about these two sides right here? They're equal. That makes it an isosceles trapezoid. Everybody write that down? Now, I didn't write down exactly what the words say, but I think the pictures kind of show what I'm talking about. All right, let's do another one. This might be it for today. Maybe we'll have time to do a little example. I don't know. At least we'll get started on the example. All right. What have we been doing lately? We start off all these like a triangle, a parallelogram, and then we throw in some what? Some diagonals, right? Okay, so we're going to do the same thing here. All right. Now, do the diagonals bisect each other on a trapezoid? No, they don't. No, they don't. Because when do they bisect each other? When it's a what? When the figure is a parallelogram. Good. Okay, when it's a parallelogram, they bisect each other, but they don't bisect each other on a trapezoid. Okay, if you look at it, just kind of looking at it, see how that side right there is a lot shorter than that one right there? All right, so they're definitely not. But there is something true about the diagonals. Take a wild guess what you think might be true about those diagonals. We'll go, what's that?
Double.
And by the way, I had to tell you that this was isosceles, okay? This isn't true on just any old trapezoid. It's only true on isosceles. So we're basically sticking with isosceles trapezoid in this lesson, okay? All right, so if it's an isosceles trapezoid, what do you think that BD and AC, what does it look like, just to you? Looks like they're equal to each other, doesn't it? And they are. We have a theorem that says that. It says that an isosceles trapezoid, a trapezoid is isosceles if and only if its diagonals are equal to each other. So, if I knew, let's do this. Let's say I knew that AC was equal to BD. What if they told me that? So that's what? That's given. Remember that? So if it's given that AC is equal to BD, what could I say about this whole entire trapezoid? So if these two are equal, then it's an isosceles trapezoid. Isosceles, I'll just shorten trapezoid to trap. Okay? Everybody see that? So if the diagonals are equal, then it's an isosceles trapezoid. Okay? What if I don't know that AC and BD are equal, but what if I know that AD and BC are equal? Well, it's isosceles, you know that, right? Just because of the definition. But since it's isosceles, what must be true about the diagonals then? They must be equal to each other. You see how it's just flipped around? Okay? So this one says, if the diagonals are equal, then it's isosceles. The other one says, if it's isosceles, then the diagonals are what? Are equal to each other. All right? So that's what that's saying. I just didn't write the second part of it down. I guess I could. I could say, if it's isosceles, let's just shorten it, isosceles trapezoid. Dylan, where are you going? If it's an isosceles trapezoid, then, okay, what's true? Then AC is equal to BD. See the difference? All right, they're converses of each other. All right. Yeah, we're not going to have time to do the example, but we got a little bit more to do. But this lesson, even though when I wrote it at the top, I just said trapezoids, there's actually two parts of this. It's trapezoids and kites. All right, so tomorrow we'll finish up the trapezoid. Probably when we come back next week, we'll finish up the kite part of it. All right, so that's it for today.